NASA is poised and ready for its test launch of the Orbital Sciences Antares rocket from the Wallops Flight Facility in Virginia that will set the stage for sending a new commercial cargo ship to the International Space Station. We spoke with Bruce Manners, who is the Orbital Sciences Project Executive. He is there at the Wallops Flight Facility to support the test launch. Hi, Bruce. Thank you for taking time out to talk with me today.
Hello. Well, not a problem. I'm looking forward to talking to you.
The test rocket has rolled out to the launch pad on April 6th, and it's now poised at the NASA's Wallops Flight Facility there on the Virginia's eastern shore where you are now. Let's talk about Antares and this test flight.
Sure. The Antares is, of course, a new rocket being developed by Orbital Sciences. It's a two-stage rocket. The first stage is powered by two Aerojet AJ-26 engines. That's a LOX kerosene fuel mixture. And the second stage is a solid built by ATK, Castor 30. And so it will launch from the eastern shore there at Wallops up the Mars pad and place in orbit a Cygnus simulator. The Cygnus will be the spacecraft that Orbital will ultimately launch and take to the space station carrying NASA cargo. And the simulator that we put on here really is intended to mimic the mass properties and be a test payload, so that before we put the valuable Cygnus spacecraft on the thing, we wanted really a mass simulator, so that this mission could really test out all of the phases that you're going to see with a cargo demonstration services mission. So the rocket's going to fly the same trajectory. It will mission profile. Everything will mimic exactly what they'll do later on with the demonstration mission, and then ultimately under their CRS contract. So this was an early risk reduction effort, so we could try to retire the risk. Whenever you field a new rocket, there's always a risk for the first few missions that you haven't really quite captured everything exactly right. So this gives us an opportunity to test it out and wring out the system a little bit before we start flying it to the International Space Station.
I know I've seen in some places it's described as a medium-class launch vehicle. What does that mean exactly?
Well, there's several different classes of launch vehicles. There's the Atlas, which tends to take up the heavier payloads, the Deltas, and then this is a little smaller class. It just takes up a little less capable as far as payload, but it actually fits really well with sort of the medium to commercial satellite payload capabilities. I don't know have those figures offhand exactly, but it's just a little smaller vehicle than say the Atlas V. So they intended to carry smaller satellites, or in this case, the Cygnus spacecraft that will take up cargo to the space station.
And can you tell me how far can it go?
It's going to put the Cygnus spacecraft right into low Earth orbit. It's going to be a mission payload or mission trajectory that really mimics exactly what they'll do with the International Space Station missions. It will put the payload into orbit. The Cygnus simulator, we're really considering the mission over from a payload delivery perspective at payload separation. But it will put the simulator into orbit, and it'll actually stay in orbit for up to a week or as much as a month, depending on exactly where it puts it into the orbit. So it's going to put it the whole way.
So the test flight of Antares rocket is scheduled to take place at 4 p.m. Central Time. What do we, as spectators or folks here on the ground, expect to see? Can you describe its flight path? Will anyone on the ground be able to see it?
You're going to be able to see this pretty much from anywhere on the eastern seaboard. And I know that Orbital Science has posted some things on their webpage so that give folks really the opportunity to try to figure out exactly where they might want to be and what directions they want to go look at. But if you're lucky enough to be at Wallops, you're going to see the rocket ignite on the pad and take off and start running downstream. We're going to be able to get photos and videos of the as it's leaving the area here, and then eventually, of course, it goes into orbit, and we'll be able to see it when it's up there. But I think it's going to put off a great show, and folks are going to be able to see it from even places like Washington, D.C., where you don't really get to see a rocket very often. So if you go to the Orbital Science webpage, I think NASA has some as well. There's a bunch of imagery that's out there that tells you where to look. I've even seen some Google Map images where if you're standing in Washington, D.C. on the mall, it tells you what direction to look and where you'll see it in the sky.
Real quick, you mentioned also that this is the risk reduction test flight. So how many missions are scheduled under this contract? There's the test flight, and then what?
Well, under the initial agreement we have that I've been working under, the COTS, it's actually a Space Act agreement, which is a little different. It's a contract mechanism than a traditional contract, because it's really a partnership agreement. We have just the two launches under that. There's this one, the test launch, and then we will have a full demonstration mission, which, if all goes well with the test launch tomorrow, then we're hoping as early as June or July, or this summer anyways, we will have the demonstration mission that will go to the International Space Station. And then under the Orbital Sciences and NASA, the Space Station program, have what's called the Commercial Resupply Services, or CRS contract. And under that contract, Orbital has 8 missions assigned to them, where they will take up real cargo, real payloads to the International Space Station. It'll be food and water, new experiments, and then once that's all up on orbit, they'll unpack that all by the astronauts, and they'll put back into the spacecraft, actually trash. It's going to be more or less a trash vehicle that they'll pack up with all the stuff that they've gotten on orbit that they don't need anymore, and they don't want anymore, and there's no use for it. They'll pack it into the spacecraft, and the spacecraft will take it away from the International Space Station and burn up on reentry.